So, a couple of lessons ago, we were doing box plots. Remember, and we're doing like side by side box plots to compare, like two separate pieces of data. You remember that? Like we were trying to compare, let's say, like home runs in 1927 and then home runs in 2007. So that's an important thing to do. But it's also important sometimes when you have one data set, right, to compare one individual to the rest of the group, right? And this is done a lot in like SATs or whatever, or percentiles, like when newborns, like when you take them to the doctor, they measure the height, the weight, and they say, okay, like he's in the 97th percentile for height, or you know what I mean? So that's what we're going to do today. Z-scores help us compare one piece of data to like the peers or like the others in the group. Okay, so what we're going to focus on is the location of one data value to the other data values within a data set. Okay, all right. When we were doing the standard deviations, and then when we did this in the last lesson, right? Let's take a look at what we were doing here. So we had the mean right here. Okay, this is the mean right there. And then we went one standard deviation and then two standard deviations and so on. So if for this one, the mean was 67, right? And this was what? This was heights of students. If a student was 69.5 inches tall, they were exactly one standard deviation away from the mean, right? And then if they were 72 inches tall, there were two standard deviations away from the mean, right? But can you say that all the students are either 67, 69.5, or 72 inches tall? No, that's silly, right? You have so many students that are 68 inches tall. You might have so many that are 68.2 inches tall. So suppose you had a student who was 68 inches tall, right about here, okay? Now that's not a full standard deviation away, but how far away is it? Like this is about, I don't know, is this half a standard deviation away? Is it 0.4 standard deviations away? Sometimes you really want to know exactly how far that one value is from the mean. That's what we're going to do today. That is a z-score. Okay, so a z-score is the number of standard deviations that one value is above or below the mean. And if the value is above the mean, it's a positive number for the z-score. If it's below the mean, it's a negative number for the z-score. Okay, there is a cute little formula for z-score, which we're going to memorize. And it's basically, you take the data value minus the mean over the standard deviation. Okay? That's it. And you're always going to round to 2 decimal places. So let's go ahead and do this one. We have to find z. So z is x minus x bar over sigma. Okay, so x is 24 minus 29 all over 4.2. How much is that? Any ideas? Negative 1.2. Can you go to 2 decimal places?
Yeah, so negative 1.1 or 0.19. So.
Negative 1.19? Yeah. Negative 1.19. Exactly. Right? That's it. That's all. Okay, so now in the next one, we need to find x. Z is given. So z is negative 1.73 is equal to x minus x bar 48 over 2.3. Okay, we got to do a little bit of arithmetic here. Multiply both sides by 2.3. Then I believe this is negative 3.979 equal to x minus 48.
How'd you do it in your head?
I didn't. It was pretty convincing, right? I have them all solved beforehand. So if I add 48 to both sides, x will be 44.021. Now we set to round the z-score to 2 decimal places, but if it's the x or the x bar, you have to round it so that, these two make them have the same value, like the same decimal value, right? So round x and x bar to the same decimal place. So if x bar was rounded to the nearest whole number, we're going to round this to the nearest whole number, and we're going to make this 44. Okay? All right. So take a look at this one. Imagine you're comparing 2 individual data values, right? And you want to see which is more extreme. So now take a look at the 2 that we're going to be comparing. There is a 76.2 inches height. Okay, so you have an individual with a height of 76.2. And then you've got another individual with a weight of 237.1. And you want to know which of these is more extreme. Okay, now we're not judging, right? We're just saying, like, mathematically, which is more extreme, which is farther away from the mean. Okay, you can't compare the 2 of them to each other directly because that's like comparing apples and oranges. It's height versus weight. So what you have to do is you have to compare the 2 data values by finding their corresponding z-scores. Okay, so why can't I? Okay, so all right, so take a look. I'm going to color code this. The heights have a mean of 68.34 inches and a standard deviation of 3.02. The weights have, x bar here and sigma there. So we're going to find the z-score for both of them. All right, so let's do this. So for the first one, z is 76.2 minus 68.34. 3.02, and then the second one minus 26.33 over, oh no, I did this wrong. Sorry, it was supposed to be 68.34 minus 172.55 over 26.33. All right, did you guys do these? What did you get for the first one? 2.60. And what did you guys get for the second one? 2.45. Okay, so which one do you think is the more extreme value? The height, right? Because it's more standard deviations away from the mean. It's farther away from the mean. So we say the height of 76.2 is more extreme, inches, because it is further away from the mean.
Are we going to have a test on this or just the final?
Oh, test.
Do we have a test on this?
Yes. And you also have to write, I don't know, you have to check, but you have to also say all of these things in like coherent English sentences, okay? All right. Okay, the 23rd is a Tuesday. Okay, so next, before I move on, let's go back up here for a minute. Okay, so look, these were, again, the standard deviations from before, right? For the heights, okay? So suppose you have, somebody who is like 63 inches tall, and then you have somebody who is like 72 inches tall, okay? And you want to know what is the ranges of z-scores between these two, okay? So what do you think the z-score will be for this one? It's -1.5, and this one looks like it's about 1.45 or something, right? So you can say, if let's say everybody in the class is from 63 to 72 inches tall, you can say, okay, their z-scores range from like -1.5 to +1.2 or something, okay? And that's what we're gonna find now. Okay, so if we go over here, we wanna find the interval of Z values, and we are just gonna do this with a calculator because it's not worth doing it by hand. Okay. So before you do this, don't plug anything into your calculator yet. Before you do this, you have to first draw a distribution that represents what it is that you're trying to find. All right, so let's try to draw here. Okay. So if I want the middle 50% of the data, this is what it's going to look like. Let's draw a normal distribution. All right. Whoa. Okay, so here's a normal distribution, just like you drew for your homework. What we want is the middle 50% of the data. So that's about there. That's 50% of the data. Does that make sense to you? We're eyeballing. Okay, that's 50% of the data. Now, if this is 50% of the data in the outer regions, 25 each, right? So if this is 50%, that means in the outer regions, I have 25 and 25. Okay, so now imagine this bottom line was actually a number line. Okay, starting at 0. Okay? Okay, by the time I have progressed this entire distribution, when I reach the end, that's 100% of the data, correct? Here at the very beginning to the left is 0% of the data. Okay, so this is 0% of the data. And then by the time I get to this point, how much of the data have I gone through? 25%. Good. So that's one boundary of my 50%. Now, if I go to this, how much total of the data have I gone through now? Plus the 25, so 75%. Okay, it's starting at 0. By the time I'm here, I've looked through 25% of the data. By the time I'm here, it's now 75% of the data. These are the numbers that you're going to need, but you're going to need them in decimals. Oh, 0.25 and 0.75. Okay, so now let's go ahead and go to the calculator. All right, so here we're gonna follow this this right here. So we're gonna go to menu, statistics is number 6, distributions is number 5, and then we want to go to inverse normal number 3. Okay, here. Okay, now we're at number 2. Enter the decimal equivalent of the percentage to the left. So what are we going to put in? 0.25. Why do I keep doing 0? And that gives me negative 0.67. Negative 0.67, right? So what that tells you is, okay, so look, guys. Remember how this is the mean in the middle? Oh, come on. Remember how that red is the mean in the middle? The 25%, this is negative 0.67, so it's less than 1 standard deviation away. Now, let's repeat the process for the other number. So let's go to menu, number 6 for statistics, number 5 for distributions, number 3 for inverse normal. 2 decimal places. And here we're going to put 0.75. And what do we get? 0.67. Now, because the data that I want is bounded between these two, right? Where is the data that I want? It's this one. Over here, I say less than or equal to z, less than or equal to 0.067. You have to put it in the proper inequality. All right? So now, let's do this next one. Now we want the outside 20% of the data. Okay, so if I want the outside 20%, that's here and here, correct? So how much is the left portion? 10%, yes? This is also 10%. How much is the region in the middle? 80%. Okay, so again, if I pretend this is a number line starting at 0,
Wait, how can you know it's 10%? Not why don't you just be
because it's the outside 20%, it doesn't say left or right. That means it has to be evenly distributed between the left and the right. So by the time I'm at this first interval, how much is it? 10%. And by the time I'm here, how much is it? Here. 90%. Okay? So now I got to do the same thing. All right, so let's do menu, statistics, number 5 for distributions, number 3 for inverse normal. Oh, sorry, I pressed the wrong thing. Menu, 6, 5, 3. Okay, here we're going to put in what? 0.1. And we're going to get negative 1.28. Okay, now, don't do the other one. I'm going to show you a shortcut. Okay, so to do the shortcut, here's what you're going to do. You're going to press the up arrow once, twice. Highlight this one. Press enter. Now go in and just edit this 0.1 to the new number 0.9. Okay, and you get 1.28. Okay, now, the region that I want now is here and here. Do you see how this is different from the one above? Because the one above, the region that I wanted was in the black and it was bounded between these two. It was connected. Here, the region that I want is disconnected. It's like if I had, a number line like this with an OR inequality. All right, because the regions are disconnected with each other. So the way we're going to write this is z is less than or equal to negative 1.28, or z is greater than or equal to positive 1.28.
How is it disconnected?
The region that we wanted for the first one was this black region here. Do you see how it's one lump? But you want the two disconnected ones here. So the inequalities, you have to have an AND inequality here, and you have to have an OR inequality here.
How do you know which way it goes?
It always goes the same way. If it's an AND inequality, it has to go less than. And then this one, it has to go less than that way or greater than this way. All right. And guys, this was the last ever notes for this year. That's it. You're done. You are done. Okay.